In this video, I'll show you how to solve the ALEKS problem called Understanding How Average Molecular Speed Scales with Temperature and Molar Mass. To help you solve this problem, you are probably going to want to have a periodic table handy. We are going to be looking at the molecular weights of different gases. So we've got 4 different samples of gas here that we're going to be ranking them according to their average speed. And to do this ranking, we're going to be using 2 variables. We're going to be using the temperature of the gas, and we're also going to be using the identity of the gas. ALEKS is also telling us about the quantity of each gas, and we're not going to use that. That's not related to speed. And ALEKS also gives us the pressure, and we're not going to be using that either. So what we do know about the speed of a gas, it is directly proportional to temperature. So this means that as the temperature of a gas goes up, the speed of the gas goes up as well. And we're going to be able to rank one of these gases based on its speed. I've got 3 gases that have the exact same temperature. That's pretty common in this ALEKS problem to have 2 or 3 with the same temperature. This gas right here has the lowest temperature. You do have to be a little bit careful because we're working with negative numbers here. Sometimes our eyeballs see this 85 and think, oh, that's the biggest number, but pay attention to the negative sign. So this is the smallest temperature, the lowest temperature, which means that this is going to be the slowest gas because it has the lowest temperature. And ALEKS is using a number 1 for the slowest gas. So these 3 gases all have the exact same temperature, and to distinguish them from each other, we're going to be using their masses. So speed is also related to the mass of the atom, but this is an inverse relationship. So speed is high for gases that have a small mass. So we have, write that a little bit more clearly, high speed comes from having a small mass, or gases that have a small mass are going to have high speed. And this is where the periodic table comes in handy. So I have in the gases that I'm trying to distinguish from each other are these 3. I have neon, helium, and krypton. And on the periodic table, they are here, neon, helium, and krypton. And again, all 3 of these gases are at the same temperature. So to distinguish or to rank their speeds, we're going to be using their masses. Helium is the smallest one of all of them. Smallest mass means that it is moving at the highest speed. So this is the gas that is going to be the fastest. We're going to give that a 4. And then the next smallest gas is, oh, I put that in the wrong spot. The next smallest gas is neon. So that is going to be our next fastest. We'll give that a number 3. Krypton, because it is the largest, krypton is going to be the slowest out of all of the gases that are moving at negative, or that are existing at negative 56. So again, what you're going to be doing is looking for some sort of trend, like maybe like I did, you can start with the temperatures and you can pick out one gas and separate it from the others, and then you're going to go through and compare their masses.